It's a pleasure to be here, and I hope what I have to share with you guys really challenges your thinking around how we think about security, especially as we move into this new cloud native world that we're all exposed to. So let me see if I can change this. Okay, so I'm going to offer, as a part of my talk here, a new set of paradigms, and I'll explain why we need this new set of thinking, but I do like Albert Einstein's quote here that we can't really solve the problems that we have with the same kind of thinking that we had when we created them. So we're in that sort of same situation here, and I'm going to offer some crazy ideas, but I want you guys to remember this quote because it's something that should cause us to say, you know what, maybe we should rethink some of these things, even if it may seem completely contrary to everything that we may be thinking or believing in. So let me jump in. All right, so Frank mentioned briefly something about the cyber defense matrix. So this is the cyber defense matrix, and I created this when I was at Bank of America, primarily because I was in charge of trying to figure out what to do with all these technologies and companies that we see that litter our inboxes on a regular basis. And what I want you to notice is not necessarily where everything maps, but a certain pattern that will become obvious or pretty apparent as you see all these companies populate the matrix. And that pattern should be evident in that there seems to be something missing on the right side here. And I had two different theories as to why maybe there's a gap on this right side. One is what's represented on the bottom, this degree of dependency on people, process, and technology. And this was my conjecture that maybe we depend more on technology on the left and more on people on the right. But I also discovered another, I had another hypothesis as to why there's so few things on the right. And that led me to a stark realization about what we might expect in the future and ultimately how we think about what we need to do for the future. So let me jump into that. And to be able to do that though, I have to understand the future, we have to look back in the past. And so let me give you a quick history of the past as it relates to the progression of IT and security over the last couple decades. So in the 80s, IT became cheap. We bought tons of computers from Dell and Gateway and folks who make them much more affordable. But we had a challenge. And the first challenge that we ran into was just understanding what did I just buy and what business function did it support? And so we came up with solutions to help us address these. Now these solutions aren't perfect and we still have these problems, but at least we recognize that we had a new type of problem and thus we needed a new type of solution. And so the solution was things that helped us do asset management and discovery and so on and so forth. Now, I'm going to also describe this tension between IT and security over the years. But in the 80s, there was no tension because, well, for the most part, there was no security team. Fast forward 10 more years, we start seeing people send us I love you messages, and people walk into our networks, and people take advantage of insecure configs. And we came up with solutions to that as well. So things like AV and firewalls, things like security configuration guidelines. At this point, the tension between IT and the security team starts to increase because you have a team that is essentially a hobby shop that came out of the IT team. And their vulnerability management focus on they're telling the IT team, hey, you should turn that off. You should disable that feature. You should do these things that destabilize the IT environment. And as a result, we start seeing tension between the two organizations. Fast forward 10 more years, we now have all this logging that's happening. And we need eyes on these alerts. Well, one, we need to understand what these alerts are saying. So we come up with things like IDS and SIM. The security team and the IT team continue to increase in tension. And because you need eyes on these alerts on a regular basis, we have a 24/7 SOC, and the security team is threat management focused. You fast forward 10 more years. At this point, we should assume breach, and there's fires everywhere. And so we need firefighters and firefighting tools. For some organizations that have matured to this point, the security organization and the IT organization split off because the conflict of interest is too great. And so they break off and become a dedicated business unit, and it's risk management focused. Now, what's remarkable about this timeline and this history is that each decade maps pretty nicely to the NIST cybersecurity framework. So the 80s, we had an identify problem. The 90s, we had a protect problem. The 2000s, we had a detect problem. The 2010s, we had a respond problem. So, okay, well, for those who understand the NIST cybersecurity framework or know what each stage is, the next stage should be obvious, right? So the 2020s is a recover problem. So in each decade that we saw previously, we encountered a new challenge. And as a part of that challenge, we needed new solutions. And the solutions of the past did not address the problems of the present, okay? But the first question that we should ask ourselves is, for the 2020s, what type of problems are we going to encounter? What are the types of problems or challenges that will make us unable to recover? What will cause irreversible harm? And if I mapped it to the DIE Triad, well, one of the most obvious ones that we're seeing hit many different companies, of course, is ransomware. It's like the epitome of what is a irreversible challenge in the 2020s. So as I mentioned, we need new solutions for these new problems. So if I went to the market and I asked, okay, well, what do you have for me to address ransomware? I get something like this. I get a solution that really just points back to the past. And this is an actual advertising campaign from a major vendor. And I think it's very appropriate and very fitting that they use a dinosaur and invite people to come back to the 1990s. Okay, so they're saying join the prevention age, which is the protect era, which is the 1990s. And my argument to them is to say, well, I mean, yeah, more protect, detect, and respond. It's going to help mitigate the occurrences of ransomware. But once I actually have ransomware, okay, I have a 2020 problem. I have a recover-oriented problem. How am I going to address a 2020 problem with solutions from the 90s, 20s, 2000s, and 2010s? And the answer is it doesn't. It doesn't actually solve my recover problem. I need a 2020 solution for my 2020 problem. Okay, so my question again is, well, what kind of solutions are there? And it turns out, as I studied what's out there, I discovered things that already existed for a long time, like things like content delivery networks. I've discovered design principles like copy on write, where you never delete anything, you just keep appending. New types of technologies like Docker containers and serverless architectures, all things in the cloud. And then even buzzwords like blockchain. And as I looked across all these different types of solutions, I discovered a common thread across all these. And it's a new set of paradigms that I call the DIE Triad. And so the DIE Triad stands for distributed, immutable, and ephemeral. So each of these different types of things that help us become more recoverable, more resilient, seems to have these qualities of being D, I, and or E. And they offer security value too. So if I'm trying to ward off the distributed denial surface attacks, well, the best way to handle a DDoS attack is to have a distributed service. One of the challenges that we have in security is just finding the anomaly. But if nothing's supposed to change, then finding that anomaly is really easy. And then persistence is something that attackers always want. So what if you make the asset more ephemeral? But what's also more interesting than even this is that each of the attributes of DIE actually reduce my burden for CIA. The more distributed something is, the less I need to worry about the availability of one thing. The more immutable something is, the less I need to worry about the integrity of it. The more ephemeral something is, the less I need to worry about the confidentiality of whatever that is. So this concept, this new paradigm, is what I'm offering as a way to think about how we do cloud security as well. When we build in the cloud, we want things to be DIE and not actually CIA. In other words, we want to first take a step towards making the system, whatever we build in the cloud, to be DIE and not actually have to worry about security at all. And one way, to give you a sense of why this may be a consideration, is if we look at the traditional risk analysis equation, risk is this product of likelihood and impact. And the traditional way that we look at likelihood is it's made up of two major factors. It's vulnerabilities, and unfortunately we have this never-ending conveyor belt of vulnerabilities, and threats. And again, we have threats that never seem to go away either. And furthermore, vulnerabilities get worse with time, and threats get better with time. Vulnerabilities age like milk, and threats age like wine. And the combination of that means that likelihood just continues to go up, and thus risk goes up as well. But what if we can reduce impact? What if we can drive the impact of the assets or the things that we care about to be as small as possible? And when we think about the goals or the way that we manage likelihood today, it's largely through the activities associated with the DIE Triad. But if we're trying to minimize impact, that's something that we can do with the DIE Triad. What if we actually spent more time and focus on reducing impact first, okay, and not just trying to handle the likelihood side of the equation? To give you another analogy, another way to think about this is to use, I'm going to use a what's called a pets and cattle analogy. This is something that's common in cloud native environments. So pets are things that we care about. We give it a familiar name. And when it gets sick, you patch it, you take it to the vet, and you like giving it hugs. And these are things that we all love and care for, things like our social security number, our laptops, the server under the desk. On the other hand, you have cattle, and the cattle are things that you don't even have a name for. This is branded with some obscure string of characters. And then when it gets sick, you basically shoot it and you move on. And these are things like your Docker containers, Lambda functions, credit card numbers that continuously change. When it comes to pets, we have an obligation to secure those pets. And so we CIA those pets. However, when it comes to cattle, we designed them to DIE. And cattle is another analogy or another adage I oftentimes use is pets are fine on-prem. Pets on-prem, cattle in the cloud, okay? Build your pets on-prem, build your cattle in the cloud. When you're building things in the cloud, you want to be extremely careful, if not altogether avoid this lift and shift model of moving your pets, migrating your pets to the cloud. To reinforce this, why that's not a good idea, let me also offer this other perspective, which is it's okay to feed your cattle to your pets. It's not okay to feed your pets to your cattle, okay? Moving your pets, moving your sensitive things outside of your on-premise environment into the cloud is asking for trouble. Now there's ways to ensure that that is properly secured and all, but if you're really wanting to migrate to the cloud, if you want to do what we call cloud security, then we need to think differently about what is it that we're trying to secure. And if we're trying to secure actually cattle, do we need to even secure it at all if they've been designed to be DIE, okay? Now, the other aspect of this is DIE is actually extremely measurable. And one of the challenges that we have in our environment is just being able to quickly discern what is a pet and what is cattle. And there's a bunch of different assets that you might have in your ecosystem. And this is a quick snapshot of some assets that I have for this project that I volunteer for called Project N95. We have 20,000 some assets. Which of these are critical? Which of these are ones that are pets? Now, I can manually designate these, but there's another way that I found to actually systematically discover what our pets are, what our cattle are. And that is using the measurements of DIE. And so here's an example. I'm going to measure ephemerality. And ephemerality is just how long lived something is. And if I can measure how long lived every asset is in my ecosystem, I can then set an arbitrary threshold. Let's say this is on a logarithmic curve, so this is like 60 days. Anything older than 60 days, I'm going to consider that to be a pet. Anything younger than 60 days, I'm going to consider to be cattle. And so I now have a way I can understand which are the assets I need to protect, which are the assets that I can get rid of, or more importantly also, which assets do I need to keep an eye on so that they don't become pets? Which of my cattle do I want to shoot on a regular basis so that they don't become newly adopted pets? It also gives us a perspective of what kind of policies or how should we think about the type of assets that we create and how we manage them and how we govern them. What we want to try to push for is to have design patterns and policies that basically have fewer pets and shorter lived cattle. And in the context of resiliency, I mean, consider this for a moment in terms of the shape of this curve. consider a shape of the curve that looks more like an L, okay, where you have very few pets and very short-lived cattle, versus a shape that looks like a 7, where you have all these very long-lived pets and very few of any cattle at all. And I should, in case this pets and cattle analogy may not work for you, let me offer another analogy that may also make sense too. So consider the cells in your body. Okay, what are some of the longest lived cells in your body? They are your brain cells. They are your pets. What are the shortest lived cells in your body? They are your skin cells, and that's like cattle. What do you call a skin cell that lives too long? It's called cancer. And what do you do with cancer? You cut it out. You get rid of it. And that's what we're trying to do here. We don't want cattle to become pets, because if it becomes a pet, you're going to have a whole burden of having to own this pet and making sure that you have proper veterinary care and all that kind of stuff. Now, in terms of the shape of the curve and what is resilient enough, or what is the right ratio, it turns out there's actually a way to calculate this. For those organizations that are highly regulated, one of the things that I'm certainly familiar with being at previously at a highly regulated organization was this emphasis on resiliency. And it's been no surprise to me that the 2020s, there's been a huge emphasis on how do you become more resilient as an organization. But how do you actually measure that? And it turns out the DIE helps us do that, because I can take, for example, all the values of ephemerality that you saw earlier and map them in such a way that I can get this mathematical value that you see here. There's a whole bunch of research that's been done to do this. And so I'm not going to get too far into the math, but there's a way to get this exponential value that tells you how resilient you are relative to some benchmarks. And it turns out you can actually, again, literally benchmark yourself against a lot of academic research around what actually is a robust environment. What exactly is resilient? And more so, what might be too resilient that will create additional costs for you? Now, if you're critical infrastructure, maybe it's okay to spend more to be more resilient. But if you're not, do you need to be as aggressive in being as resilient as you might see here? So 1.3, the beta value here is suggesting that I'm actually more resilient, but it may come at a higher cost. And again, that might be expected in a critical infrastructure, but if you're not critical infrastructure, maybe you can deal with a higher value. But not too high, because once you get too high, then you become less resilient. And there's a ton of research on this. I don't plan on going over it too much, but just know that this is something that's been well studied, and it's kind of cool to think about as well. There's also other ways to measure resiliency. And here's an example from this guy, Will Larson. He tried to go and measure, or rather put a score to servers. Okay, and this is the model that he suggested. The input metrics being things like your server age and how many people have root or SSH, how many modules have code components have CVEs, and based on that, you get this grade from A through F. But if I overlaid this notion of the DIE Triad, where at least I can measure the I and the E part, I can then also have a sense of which of these are cattle and which of these are pets. And it turns out the higher grade it is, like with an A, where it's more immutable or more ephemeral, then it's more cattle-like. And whereas the servers that are graded F tend to be more pet-like. So this is an other interesting way to measure this. And I find DIE to be extremely much more measurable than CIA. Just as an example, how do you measure confidentiality? Really hard, right? I mean, is there even a measurement? How do you measure ephemerality? Very easy, right? And if ephemerality helps counter confidentiality or offset the burden for it, then great. Let me measure how ephemeral my systems are, how ephemeral my assets are, how ephemeral my data is, right? And it gives me a sense of what my residual burden might be from the CIA fund. Now, in terms of, okay, great, this is great. And I like the idea of DIE, let's say, well, how do I actually go play this out? It turns out there's actually a lot of capabilities that align nicely to the DIE Triad. So here's just a selection of Cloud Native Computing Foundation capabilities that are out there. And these all align in some way towards being, helping you be distributed or more immutable or more ephemeral. these are, the way I analogize this is to say, these are like bricks. Before we were building with hay and straw. Now we're building with bricks. Now you can still build a pretty crappy wall with bricks, but at least we have a sporting chance of building a more stable, more defensible infrastructure. And that's what we want to be able to do by using these components that are more D, I, and or E. But we also want to be able to share design patterns. We want to know how to build a better wall using these bricks, not just build a crappy wall with bricks laid out, in some disorganized fashion. And whether it's CNCF capabilities or capabilities that are available, and then you saw my cyber defense matrix earlier. This is my attempt to try to map it to the cyber defense matrix, the 5 asset classes of devices, apps, networks, data, and users or identity. But one of the things I wanted to point out here was just that there's a lot of opportunity for innovation too. I would love to see this chart fully filled out. And some of it's just because I haven't been exposed to a lot of different tools out there. But how much better will our lives be if we can have many options for our business, our developers, our business partners in terms of how to build things to be more DI and or E. And I was going to mention, you can also apply DIE, of course, to native, cloud native, the CSP native capabilities. So here's just an example of some of the services that are available in AWS and how they map to DIE as well. Now, as I mentioned, in the context of how I think about applying DIE, there's what we wanted to try to do from a policy or how we think differently about this whole practice of security. What we want to do is to try to disincentivize or avoid pets as much as possible. But the problem is, once you have a pet, guess what? You can't get rid of it. It's not like a COVID pet. This is a family pet. And you don't get rid of family pets. You pretty much wait till they die, right? But every opportunity that there is to fully decommission a legacy system or to replace it with something that's better, we should definitely try to take advantage of that. But the other thing that we also want to make sure we're very cautious and deliberate about, intentional about, is avoiding new pet creation or new pet adoption, okay? Remember, ephemerality is one of the measurements for DIE. Well, ephemerality naturally increases with time, right? How long-lived something is just increases naturally just with time. So if you don't do anything, all your cattle are going to become pets over time. And what you don't want to have happen is for that to be done unintentionally. We're always going to have pets in our environment. There's no question about it. We're not going to get rid of every pet out there. What we want to do is just be very intentional about the pets that we choose to adopt. And so when we think about the kind of controls that we want to put in, we want to put in controls that says, hey, it looks like this cattle that you have is starting to look and feel like a pet. And if you want a new pet, more power to you, but just make sure that you know that you're signing up for a lifetime of love, care, and attention. And you better make sure you budget for veterinary bills. You better make sure you budget for these sort of things that are important to ensure that this pet is properly taken care of. Because if you don't manage this properly and this pet runs out into the street and gets hit by a car, you're going to have the SPCA or the CCPA come after you saying, hey, you just had a data breach of PII, and now you're in trouble. And just to give you context of, I'm trying to live this out where I'm working at JupiterOne. So I'm the CISO here at JupiterOne, and this is my way I can keep track of the pets that I have in my environment. I believe I can say pretty confidently that the number of pets I have in my environment is less than the fingers and toes that I have. But I'm keeping an eye on those things that might become a pet. Okay, I want to make sure that that they get slaughtered. Okay, and one of the numbers that you see on the bottom right here, the number of slaughtered cattle. I mean, I want that number to be as high as possible. I want that to continually increase because it tells me that we are keeping cattle and not allowing them to become pets. And again, if there is a pet that shows up, I want to be very intentional about adopting it because that creates more burden for me. Because as the chief veterinarian, that just creates more work for me, right? For every pet that we have, I have to practice CIA. So what I spend a lot more time on is being a pet control officer. How do I limit the number of pets that I have in my environment? And when it comes to cloud again, the cloud is designed for cattle. And so if you start building a pet in the cloud, that's a danger sign. That's something that you need to be very mindful of, saying, okay, what are we doing here? Are we actually using the cloud correctly? It was when Frank and I, when Frank invited me to talk about cloud security, in some respects, I kind of saw it as a misnomer, right? If you're doing cloud right, you don't need security. Now, that's a bold statement, okay? And there's a degree to which, it's crazy talk, right? There's so many ways that we can mess up how we do things in the cloud. But consider the reason why we care about those things is because we have pets in the cloud. What if you can design it so that you just have cattle? And the cattle, you don't care if it gets compromised. Again, this is an extreme view. And I should also mention, just as much as we can't have perfect security, just as much as we can't have perfect CIA, we're not going to have perfect DIE either, okay? But it's a goal. It's a goal to say, how do we build systems to be more DIE-like? Because if we're going to build in the cloud, then that's the first step that we should take. Make it as DIE as possible and avoid having, and if you can do that, then you can avoid having CIA. Where you fall short in the DIE triad, you have to follow up with the CIA triad. So if you can't make something distributed, then you got to make something more available. If you can't make it immutable, then you have to make sure you worry about integrity. If you can't make it ephemeral, then you have to worry about confidentiality. But if you can focus on making something as DIE as possible, again, you lessen your burden. Your veterinary bills get lower as a result. Now, you may wonder, okay, this is great, makes sense for servers, it makes sense for infrastructure. How does that work for data? It seems like data resists being anything but a pet. And I think it's interesting in the context of the cloud, shared responsibility model, where things, I don't know if this was intentional, but it turns out the things on the bottom that's more tied to AWS tends to be more cattle-like, whereas as you go up to the customer stack, it looks more pet-like. And I think there are tools and resources out there like CWPP, CSPM, CNAP, all these buzzwords that you hear from Gartner that help us make these things that are in the customer side more cattle-like. But I think it's interesting that customer data still sits at the top. And as I mentioned, customer data seems to resist being anything but pets. But it turns out there is actually a new emerging set of technologies out there that give us an opportunity to even make the customer data cattle-like as well. And that set of technology is what we call privacy enhancing technology. And as I mentioned, there's still going to be pets. We're still going to have some degree of pets, but we want to minimize that number. And as I look, what was interesting was as I looked at these privacy enhancing technologies, a lot of these I didn't really understand the context behind what problem they would solve for me in security. But I realized as I put them, as I aligned them toward the DIE triad, I realized, okay, some of these technologies that you need a math degree for, I could translate them to saying, okay, these make data more ephemeral, or these make data more distributed. I haven't found anything that makes it immutable, but maybe someone who knows the space better than I do can point it out. And there's other technologies or techniques that you see that manage pet control as well. But the point is that if you apply the DIE triad towards something that seems to resist being anything but pet, you discover that there is a whole new set of technologies called privacy enhancing technologies, which ironically also has the acronym PET, but it has these technologies actually help us turn data pets into data cattle, or basically enable us to work with data cattle from the very beginning so that we don't have to have all these pets reproduce themselves and get replicated over and over again inside of our environments. Now, there are a couple other things that I found really interesting about the DIE triad. And one is that it's already something that, it's a struggle to get the business to care about security. But I found that the business already is pretty highly aligned with the concepts of DIE. And to explain that, let me show you something that I think many of you all might be familiar with around the OODA loop. So OODA, of course, stands for Observe, Orient, Decide, Act. And you have this attacker OODA loop. As defenders, we have an OODA loop that's larger than the attacker. And try as we might, one of the things that we try to do is to get inside the attacker OODA loop. And but try as we might, we can't. Instead, though, there is an entity that already naturally lives faster than the attacker. It's inside the attacker's OODA loop, and that's the business. The problem is that when we start overlaying CIA, or when we start overlaying security on top of this, the OODA loop for the business gets larger. And so we lose that speed advantage. But again, the business already naturally has an incentive to move as fast as possible. So if I can instead restore this natural business OODA loop with DIE, then it enables me to actually get to a point where I don't have to worry so much about defending against the attacker, because I already have first mover advantage. Furthermore, as soon as the attacker figures out maybe how to break into my environment, I've already moved to the next thing. And it's not me that's moved, it's the business, okay? The whole notion of moving target defense, I love the idea behind it, but I want that to be driven by the business, not by security. And I want that to be driven by the business because of the business agility that they want. We want the business to move fast. And one way to do that is to embrace the DIE principles. All right, let me skip that for a moment. And one of the interesting things is when there's a lot of startups out there that tend to be more inherently secure, not because security was their initial goal, but because they are already adhering to this concept of moving as fast as possible, aligning to DIE principles because they're using cloud infrastructure. We want businesses to move to cloud, actually to build in the cloud. I hesitated in calling it move because a lot of people think of that as lift and shift. That's not what we want. We want to rebuild in the cloud, and we want to rebuild in a way that aligns against DIE. And one other framework that I also thought through, and this was something that a friend of mine he used to be at CISA, George Korfman, shared in the past around this notion of defensible infrastructure. So CISA, for those who know, they have this motto, which is defend today, secure tomorrow. Well, defend today is really hard because we are largely built on indefensible infrastructure. We struggle in operating it properly and having the right discipline around that. As a result, we have situational blindness, and as a result, we need tons of countermeasures. That's what we have to defend today. When we talk about securing tomorrow, we want to start with defensible infrastructure and then operate that with a high degree of discipline and understanding of how to run this defensible infrastructure. If we do that properly, then we have great situational awareness and very few countermeasures that we need at the end. When it comes to the old model we're operating, when we think about defend today, that is largely centered around the CIA Triad. The countermeasures are all tied to the CIA Triad. But if we can build systems to be distributed, immutable, and ephemeral, then we're building on defensible infrastructure. And so our ability to secure tomorrow is really, I think, foundational. And the DIE Triad gives us this defensible infrastructure that allows us to be more secure tomorrow. And it's not more secure because the infrastructure itself is actually secure, but secure because we have less to have to worry about. We have fewer countermeasures that have to include. It's already something that if something gets blown away or it gets ransomware, I don't really care because it was meant to get blown away anyway. So let me finish up by talking about what is at the end of this 5-decade story that we started with. So 2020s is the age of recover. The challenges that we'll face are those irrecoverable attacks. My proposition is that the solution is the DIE Triad. Now, this tension between IT and security, I think it's going to resolve in one of three ways. And it's going to collapse into the CISO, it's going to collapse into the CIO, or this other option that that helps us, that we can pick as far as our destiny. Let me explain what these three are. So the first one is if the CISO wins. Okay, and I'm saying this from as a CISO, and I'm saying this to a whole bunch of security people, so this is heresy, I'm sure. But if the CISO wins, I think we will end up in a very fragile environment where our burden for securing pets has grown to a point where it's we will just have too many pets to have to deal with. Our job as veterinarians, we are of course incentivized to have a lot of pets, but honestly, we have way more pets than we can deal with. So I don't think this is the destiny that any one of us wants, because even though it may give us job security, it is not the future that we should hope for. And the future here is saying everything needs to be secured. Okay, that's not the goal in my view, or that's not the goal that we should aim for. The next one is what some of us call resilient. And this is where I think the DIE Triad comes in. The DIE Triad allows us to be more resilient, as I discussed previously. But what's actually a more interesting goal is the state that's called anti-fragile. And this is a term that was coined by this guy, Nassim Taleb. And he offers this notion that the opposite of fragile is not resilient, but this notion of anti-fragile, where with fragile, when you bring harm to it, it breaks. But with anti-fragile, when you bring harm to it, it gets better. And the harm that we want to put towards our systems is a very deliberate harm to discover an environment where we believe it is very DIE-like, where there's some residual pets, okay? The goal here is to make the system stronger by shaking the system and discovering those pets that we weren't aware of, or those things that tend to be more pet-like, okay? And the goal here is ultimately to make the system more and more anti-fragile, stronger, because we're slowly removing those things that create that aren't DIE-like within our system. As I mentioned, there's no perfect security, and just as well, there's no perfect DIE either. The goal here is, over time, we continually do things like chaos engineering to bring harm to our environment, to test our environment, to find opportunities to remove these pets, and ultimately come up with a system that's far more anti-fragile. And I think the cloud is really well positioned to help us do this. So to wrap up, I think the next era in security, we're going to see a bunch of irreversible attacks. It's going to fundamentally undermine our ability to recover, and we are already seeing this. We can have more protect, detect, and respond, but that's insufficient against any of these irreversible scenarios. And again, the idea behind the cloud is, can you actually design systems in the cloud so that you can minimize, if not completely get rid of, protect, detect, and respond? Again, it's a goal. It's that extreme view of DIE. I don't think we can't achieve that today. I don't think we'll ever achieve that, which means that we'll still need some degree of CIA. We still will require some degree of protect, detect, and respond, but make the first goal to not have to need it at all. Because that's ultimately, I think that's what we want to, our best countermeasure is let's avoid pet creation altogether as much as possible, promote cattle creation. And I'll leave you with my my motto, which is death to CIA, long live DIE.